is we want to give it some information. Here's nutrition label. And hopefully this should return a JSON that's going to then update. There we go. Let's go again. Hit update. You can see we ate some more protein now, a little more carbs, some more fat, and yeah, way less calories. Hello, everyone. My name is Metfi. I'm a machine learning engineer at Roboflow. And at today's webinar, we're going to be going through Qwen 2.5 VL, our most recent VLM addition to the platform. So let's get straight to it. So what is Qwen 2.5 VL and why is it important? Qwen, I believe, stands for thousands of questions. It's a model by Alibaba that was just recently released and demonstrates some really cool performance. The most important thing about Qwen is that it's open source. So you can imagine, for many reasons, that is really cool. It allows you as a user to fine-tune the model, to deploy it on your own any sort of personal API, edge device, anything like that, or hosting. So you do not have to send API calls, pay for API calls to someone. You can fine-tune the model to the things that you want, and you can inference it and do lots of cool stuff with it. In addition to being open source, this model is also state-of-the-art in a lot of ways. So it comes in three sizes. There's the 3B, 7B, and 72B models. Each one of them is unique in a way. 72B is currently state-of-the-art for the majority of vision and language tasks. But so we in Roboflow currently support the 7B model. And as you can see on the slide here, it basically beats GPT-4o Mini in a variety of benchmarks and tasks, which is pretty significant since GPT-4o Mini is one of those closed-sourced models that you can only do things with through the API. And here you have something that is open source, and you can, and it's basically SOTA. So pretty huge on all fronts. And so some notable things about Qwen is that it is really enhancing the vision capabilities overall of VLMs. It has some really cool things like understanding videos, doing like a long videos modeling. There's like videos up to an hour or more. There is a function calling and being agentic performance. So there's about like you can literally use your computer tools and do things like that, which is really impressive and seems to be a very hot trend with where the computer vision and VLMs are heading. So it's really cool to have an open source model that can already do that. It also can do some really cool sort of object localization, just visual localization of things, not necessarily objects. And then the constraint output generation, so it can produce JSON, COCO labels. If you request it with natural language, it is actually going to be able to do that right away, which is pretty cool. And yeah, it has some just like really advanced visual scene understanding. And I'll demonstrate it later in an example, but basically it is surprising us a lot compared to the previous VLMs that are out there. So let's actually take a look maybe at all of the ways you can interact and do things with Qwen in Roboflow. So first off, you can fine-tune it inside of the app. So currently in Roboflow, we have this category called multimodal, basically multimodal datasets. And the way it works is you have some basically images, and for those images, so as you can see, when you label them inside of Roboflow, you provide an image, and you provide a prefix and a suffix. Prefix, you can basically think of it as a prompt. Here is a token for detailed caption, but it could be something else. You specify what that is. And so that gets fed into the model for fine-tuning together with your image as an input. And then suffix is what you wanted to actually generate. So here in this case, we wanted to caption images. So here it says that it has beers that are looking refreshing and tasty. Pretty simple task that could be described with natural language. The beauty of this is that you don't have to just make it caption images. Um, you are only restricted by what can be represented with text here. So this could be, instead of entering this caption, you can enter bounding box coordinates for beer, for example, and train the model to do better object detection, for example. Or you can add some JSON information with some specific, not sure, details about the image, maybe some metadata or something. So basically, you can train the model to do a lot of things. All things that can be represented via like the proxy of language and text. So yeah, not necessarily even language, could be just text. So that's basically how you get your data in and specify your tasks. And so once you do that, you can then, as you can see, there has been a trained Qwen model here already, but I'll first show how to train one. So you have a version of your dataset, you just create a new version from the dataset that you have. Here we just do a resize for 12 by 412. Qwen is a pretty heavy model, so I would recommend definitely using smaller images to for more seamless performance. And so we will do custom train. So you can see our family of VLMs here, and Qwen is the new one that's added. So we will just go ahead, put that here, get through this, and so we have option to train it from a previous checkpoint, which is basically other Qwen models that we have trained before, or we can train it from just a public checkpoint, and which is just Alibaba's weights. So let's just do it with the public checkpoint with the Alibaba's weights. And so this is gonna kick off our training ground at some point soon. And so once we do that, we will have like a trained model here, Qwen 2.5 VL, 7B LoRa, something like that. Once those train runs run, we would go ahead and we can see the training graphs. That's basically just going to display over time. How do those models train? What happens? As you can see, this is doing training. It actually starts overfitting a little bit at the end, so definitely want to monitor that. And so we can view all other images. So this is basically the predictions that it actually gave us on the train, validation and test sets. So for example, here, we can use this to see this was our prefix, detailed caption. This was the actual suffix we wanted the model to generate. This is what it generated, pretty similar. So basically, this is like a good tool within Roboflow if you don't want to like try to run inference right away. You can just check inside the app to see how your model is doing on those like validation sets, etc. And so yeah, that's kind of how you train a model in Roboflow. So once you have a model trained, you'll have an ID for it, like here. So dataset and ID. And then so afterwards, you can just grab those and use them for actually inferencing our model. So we will take a look at it now here. So today we will be understanding how to inference Qwen and what cool things we can do with it, primarily by running sort of an example where we use it to make an app that allows us to basically, given some label for nutrition, like for example this bar, um, make Qwen do some OCR, read the nutritional information from this, and give you the precise amount of fat, carbs, and protein, as well as calories. So say you just want to track those three, see how much you consume throughout the day. So we will be able to do it with Qwen without having to do any specific training for it to do OCR. We will just kind of figure out how to inference it to do that. So we will do it using workflows. If anybody's not familiar, workflows is Roboflow's kind of playground for doing anything with computer vision. You have a bunch of blocks like this for different models. You have different blocks for visualizations like bounding boxes, then some custom logic, even like sending Slack notifications. So it's a very cool kind of playground where you can do a lot of things, and I highly encourage everyone to try it out. So, but here we will just focus on the Qwen block. And so Qwen 2.5 VL block right here. As you can see, we just grabbed one of our models from food description dataset that we trained, number 68. And so yeah, note is we're using some model that was trained for some completely random task of just describing food in the image. So basically keep that in mind. It's not trained for example, extracting nutritional information. So we'll see how well could it do. And so there are multiple things here, right? We can give it a name to the model. Its input can be an image. Then you'll just output something. And here, now are the two important things. There's a prompt and there's a system prompt. What is the difference between the two? System prompt is something that we would use to kind of, ground the model in what it is, what should it do overall, like among the tasks. So here, for example, it would be your graded OCR because we wanted to perform OCR, and also we tell it to reply in English because Qwen is a model that was trained on a mix of languages, Chinese and English, and we have seen that it basically sometimes responds in Chinese, so it's not preferred in our case. We want English, so just basically adding something like that to a system prompt actually goes to reduce that and make it not respond in Chinese, which is pretty cool. You can control the behavior of this model with just natural language, which is pretty powerful. And so then we can also do an actual prompt. And in this prompt, we say extract nutrition, calories, fat, carbs, protein, JSON format. So we're telling it to extract nutrition, plus we want it to specifically output the JSON format, which is the constraint generation thing that I mentioned. And so basically here, we got this running. So now we can go ahead and try this model out. So we can do something like test workflow, for example, first. So here I'm just fitting this image of beef jerky nutrition to the model, and it's running its inference prediction with this prompt of extract a certain calories, fat, carbs, protein. And if you take a look here, this I think is exactly right. 9 grams, 14 grams, 90 calories, 0.5. Yeah, that's it. Did perfect extraction. So that's great. We see that our Qwen workflow block actually works. We can send images. We can get JSON that looks good from it for extracting like the calories. So we can now try to build an app with it and see what happens. How could we do that? So first thing is we obviously want to somehow do it not inside of the testing environment, but just like inside of some sort of call. So what you do here is you click deploy, and it's going to give you instructions. First, you need to install our library inference client and inference server you just started. So you say inference server start. And so that would ensure that all of the necessary packages for running the inference for workflows are installed. And so here, I'm already having it running just for the sake of time. It's going to take a bit to build. And the first time you run your model, disclaimer, it would take a while because it's going to download all of the model weights. And so it's going to be like, I don't know, 10 minutes. But then once this first call is done, all of the other calls will be done in a similar time to what you're seeing on my screen because the model weights are already saved and cached. And so then we can just use kind of syntax like that from inference SDK, import inference HTTP client, and give it the localhost, give it the key. I'm currently running a localhost, and I'll talk about it later. Yeah, so it'll have like already generate for you your workspace name, your custom workflow, and you will pass in the local image path as an argument. You can also, I think, pass the actual image. So let's now go ahead and take a look at some sort of advert we can build with this. So this right here, this use case is once again, we're building this app that helps us scan calories from things. And specifically, there is extract nutrition values. So we are able to extract nutrition values from different things like, so basically that's the JSON, right? We can get our JSON from the output. So basically, I will start from here. I think that's easier to understand. This is the inference HTTP client that we saw. We have our API key, we have our local host, and so the workflow, and then we pass in the image, which in this case will be a CV2 stream that we run. And whenever I press enter, it's just going to take a screenshot and pass it in here. And so then it's going to take the resulting JSON file and pass it to our processing function for JSON. This is like a function that ensures if our output JSON somehow because the Qwen is not VLMs are not deterministic with its outputs. Maybe the outputs would be some slightly different structure of JSON. It's kind of like a smarter function to handle JSONs in a little different formats to extract the needed data. So it's gonna run that and get our like final kind of dictionary with things. And so get this value, and then every time we just basically do that, it's going to save these values to a file. And so later on, this file will get picked up by this plotting code. And this plotting code would basically just plot those, yeah. And I'm actually going to drop the results from the previous one that I was doing for a test here so we can see from scratch what happens. So we're gonna go ahead and start our method that looks at us. So here's our CV2 stream, right? And then we're going to grab one for plotting too. So we grab this. We'll put that here. This is just plots for our data. As you can see, it's now empty. And so hopefully with the help of a VLM, we can actually fill it in. And we'll see how that looks in a second. So let's bring back our camera here. And so what we want to do now is we want to give it some information. So here's nutrition label. We'll give it our text of a bar. We'll pause it on a camera like that and hit enter. Let's see what happens. It's now sending an inference request to our inference server. And hopefully this should return a JSON that's going to then update. There we go. As you can see in this bar, it says 200 calories, which is right. There's 5 grams of fat, 3 grams of protein, 38 grams of carbs, so that's perfect. So let's now try to run this by this beef jerky. We had it in our testing example there, but we can run it again here to see if we can just keep scanning things. Let's go again, and let's see if we can get it. We running this. Hopefully it updates, and there we go. It updated. You can see we ate some more protein now, a little more carbs, some more fat, and yeah, way less calories, around 90. That's what it was, 90, yeah. Yep. So you can double check, try to do math in the previous two. I think it's right. And lastly, let's do a Celsius, always good for you. And we are going to also just give it here and see if it can do it. Nice. Giving it a Celsius. Let's see. There's, as you can see, there was a lot of random things. There was my headphone in the frame and a bunch of other stuff. But it seems to still have gotten it. It got 10 calories for Celsius, the thing, and then basically had 0 calories for everything, 0 nutritional value for everything. So nothing really to add to our nutrition. But as you can see, you get the calories for Celsius. And yeah, so as you can see, reminder, we did not train Qwen to do any OCR here. We only made it learn how to write descriptions of food, which is kind of irrelevant. If we just took regular checkpoint, it would have probably done the same or even better. And it is also important to notice that fine-tuning on those models, like Qwen, would not really decrease the base performance too much because of the way we do fine-tuning. There is a technique called LoRa, which basically just adds a small fraction of new weights into the model that it fine-tunes. And so this basically helps figure out how to maintain the current stuff within the model versus not giving up any of the learned cool things that the model already knows. So we just want to add some new little bit of learning knowledge without distorting any of the cool learning experience of Qwen. So that's what we do, and it works. And yeah, so this is our first example. Pretty cool stuff. We're going to now terminate this so it doesn't block us. Let's see, how does this? I'm gonna close this one, close this one. Let's probably take a look at a few more things. I have 2 more examples of how cool Qwen could be. Specifically, we can take a look at this one. Here, we're still taking the same model for description, and we're going to ask it to do object detection and scene understanding. As you can see, I'm putting in a system prompt here, and it seems to help us, hopefully, to activate the correct weights with those tokens. So we'll tell it detect workers in Coco style. Once again, I'm asking it to do constraint generation, where it gives me data formatted in basically bounding box objects with Coco style. And I'm asking it to add sublabel on what task each one is doing. So good. Basically, it requires some advanced scene understanding, because you could not just have, say, object detection model do that, because object detection models can detect objects, but not necessarily understand what those objects are doing, for example. I'll visualize this now in an example, right? So we're going to probably first just test the workflow here in the editor. You can see we provided the warehouse and we ask it to find every worker and what they do. Here it runs this, gives us the output. Look at the constrained output, bounding boxes, Coco format, and it says what each worker is doing. It looks pretty realistic. But so just to double check that it's right, let's actually run the script that would do the same thing, but also visualize it. So importantly, there is a function that resizes back from original Qwen, back to original from Qwen scale, because Qwen has this kind of like max number of pixels they can process. So internally, it resizes everything to this maximum number, and our picture is larger. So we will get this function available to people so that you can have proper resizing back once you get an output from Qwen, whenever there is bounding box outputs, in case you care about those. And yeah, basically, so what happens here is very similar. We have our inference HTTP client. We have our image that we fit in. And once we get it, we get now Coco formatted data, object detection data, that we then grab and then resize back to original scale, visualize bounding boxes, and labels that are outputs. So let's actually see if this is legit. This one, test Qwen bounding box. It's gonna take a second too. As you can see, all of the requests are around like 10 to 15 seconds, I would say. And nice, here we are. We have our construction workers, each one pretty decent bounding box, except maybe this guy, but he's not really fully in the frame, so we can maybe forgive that. And as you can see, without any training, Qwen can actually do pretty cool object detection. It is also able to say who is doing what. As you can imagine, with a YOLO or something, this might not be possible like out of the box unless you add a class for every possible action that a human could be doing. And as you can imagine, that gets really messy and not really practical. So that's kind of a cool use case where VLM can actually be helpful for those, object detection use cases where usually smaller specialized models thrive. I usually try to think about it in a way that if there's something that requires a lot of logic and you have to write a lot of logic by hand afterwards, after getting your bounding boxes or something, after getting your detections, maybe you need to retrain the models again for different settings, maybe like different lighting or whatever. Just having general better understanding of things, like where just a simple model that fits a certain pattern of the training data does not suffice. I would say using a VLM in those scenarios could be super beneficial for people, and definitely encourage folks to check it out, because this kind of nuanced understanding of the world that these models actually have is unmatched, and I think there's a lot of power for people to be discovered. So I'm very excited if anybody's watching this for what you can build with Qwen. Please use Roboflow for that if you can. That'd be awesome. So we're going to terminate this one. And let's take a look at our last example, just to kind of demonstrate this model's advanced image understanding, what I have here. So once again, same old Qwen block. And what do we see in this image? Basically, what I wanted to do is see how good is it with, because the authors claim that it recognizes a lot of things on a nuanced level, like it can recognize specific locations, specific people. So I wanted to see if it can recognize things, specifically landmarks and biological species, using this photo of myself. You see there is me holding this leopard shark, with this bridge behind, which probably most of you know where it is. But curious to see if Qwen does know. So, sorry, this is the wrong button. This just saved an output. We're gonna run it now. And so let's see, it's currently getting our inference in. So I'm asking it, yeah, just basically what is in the image, name all the landmarks and biological species. So this image shows a person standing by the water holding a spotted shark, pretty normal. The background features suspension bridge, which is San Francisco Oakland Bay Bridge, indicating that the location is likely San Francisco, California, which is correct. So pretty impressive already. It was able to tell a location based on a photo, which is not something VLMs do right away. They do that, but it's pretty advanced. And then it says the biological species being held is the type of shark, specifically leopard shark. I'm not going to read that, but this is the correct species. If you were to Google that, this shows up as the shark that I'm holding actually there. So that's pretty awesome. It knows the correct biological species for that shark just based on a photo. So it has some really deep advanced understanding of things. That's kind of the point I wanted to drive home here. So that kind of uh, finalizes my examples of things that Qwen could be used for inside of Roboflow at the moment. But I also like to show things that the authors of Qwen say it can do that we weren't yet able to test out and implement. Number one, Qwen has a Qwen VLHTML language inside of it. So basically, it developed an internal markup language for text and just like, I guess, sources of information. So as you can see here, it takes this paper photo and basically creates its own markup around it, which is kind of crazy to me. It does this with multiple sources. We're definitely going to check it out at Roboflow soon too, see if we can make it usable for people. Um, it also has enhanced video comprehension ability. This is something that we're working on adding as well. But basically, here's like a simple example of it. They record the whole video of things, just like going across some gallery with text and asking, what is all this text? So it's able to, in one pass, take in all of those frames, produce all the text. Additionally, there is understanding of videos. This one is an hour and 13 minutes long, which is insane. And that's a summary of the whole thing, which is very, very impressive. There is some additional apps you can build with it, chats, and like saying what happens at certain times, which is really important for our understanding of videos. Can enable a lot of really cool use cases for people, as you can imagine. Yeah, and lastly, superior compute and mobile engine, which is just mind-blowing. It's able to do a bunch of tool calling. If put in an environment, it could use your computer to do things. So here, I think it's been asked to book a ticket. And so it's doing that. It's going through, looking at the website. So basically taking a screenshot and then reading that, deciding which action to take. And basically, to not spoil too waste too much time, I think it gets there. Goes ahead and books something. So pretty insane. I think I got code to do Photoshop. So really, really cool. So we are working on adding this capabilities for video and function calling as well to Roboflow. And they hopefully will be in soon for people to use. And that kind of concludes my sort of overview of Qwen's use cases and just capabilities. One other thing that I would like to mention before we conclude is that basically Qwen is a pretty big model, even a 7B version that we currently offer. So whenever you run it, you want to ensure for the optimal performance that you have a GPU that is capable of doing things. What exactly do I mean by that? This current model runs in a local host, which is basically just running this inference server, right? Like the same command, uh, which has an A100 40 gigabyte GPU, and it's plenty to do all the tasks that we have in like a decent amount of time. And yeah, this is basically the cool kind of feature. It can also run those on T4 and like L4. It might just be more constrained and maybe slow. And also another thing that comes down to mind when you think about increasing up or down your GPU capacity, your prompts and your images, like say you process a video or you have long prompts or like long outputs that you wanted to generate, maybe like markdowns. The attention in Qwen, although there's a bunch of local attention windows there is still full attention layers that are quadratic. And so with every token that you add, so basically here, say my prompt was like twice as long, it would actually scale quadratically for the prompt. And basically that could really make you run out of GPU really fast and cause some memory issues. So I would encourage people to kind of keep that in mind. Balance your sequence length. Try to not be super long like I am here. I'm pretty concise. But also, yeah, if you have a large GPU that can run things fast and a lot of things, by all means do that and get the best performance. But there's just something I wanted to point out so people can have it in mind. And you can run more stuff in Roboflow's dedicated deployment here too with the GPU. So definitely encourage folks to check it out and try those things. Yeah. And so, yeah, just want to kind of conclude with the thought that basically whatever I touched on, VLMs are coming to the field, and it is important to acknowledge that they could be used for a lot of use cases. And I would say there are definitely a lot of cases where they struggle. For example, their speed, right? Qwen takes approximately, as you've seen, like maybe 10 seconds to generate an output, which is really slow for a lot of applications where speed matters. But so if you really want to go for something that's having a general understanding of the world and can generalize well, do different tasks, and do things where specialized fast models would not excel, VLMs would definitely be a really cool use case to try. For example, this OCR wasn't too bad, and it didn't really need a crazy, the OCR with the labels, I mean, of food, wasn't really super, uh, that it didn't need really fast processing. Yeah, it was able to do things zero shot, didn't need to try anything for OCR, and it was doing really good. Not a single miss in terms of calories and things like that. So where you want to try, check out this general knowledge and good performance, but are okay to sacrifice some time, definitely encourage you to check out VLM's use cases for your tasks. And yeah, if you have a lot of compute, just check them out in general. Yeah, so on that, I think we're going to conclude our overview of Qwen. For the folks on YouTube, please don't hesitate to join us live next time. We have roboflow.com/webinar, and that is basically where we host all the things live every Tuesday. Please join us next time. Very excited to see what people build with the VLMs. Please reach out to Roboflow if you have any questions. Yeah, awesome. Thank you so much.